All right, Giants. So today we are going to talk about how we find asymptotes of rational functions. Now, when I first say that, there's probably a few words you're not so sure about. So let's start with rational functions. And this is when we have a fraction, as you can see here. It's a fraction made up of two polynomials. So, for example, if we had on top something like x squared plus 3x plus 5, on the bottom could be an x squared, an x to the third, x minus 2, some sort of polynomial, which is what we were working on before break. And in this case, this would be a rational function because there's polynomial on top and the bottom. Now, our asymptote. An asymptote is a line on our graph, and it represents a value towards which the function approaches. Okay, so the function approaches this value. So I'll show you more what that looks like tomorrow. But to start off, we're just identifying where these asymptotes will occur. And what I'm going to do here, we can identify there's a couple different types. So vertical, hopefully you guys know, straight up and down. Okay, maybe it goes, this one would be on x equals 1. It could go through x equals 0. It could go through any of those values. Doesn't have to be a whole number. It could be like x equals 1.5. Okay, but those are a vertical asymptote. And then we also have horizontal or oblique. So horizontal, that's pretty easy. We just know it's going to go along the horizon, right? So this would be like y equals 1. Oblique, kind of think of that as like diagonal. So that would be one example, the line y equals x, and that diagonal, okay, it wouldn't have to be right through the origin, it just has to be diagonal in some way. So when we are finding vertical asymptotes, and tomorrow we'll talk about how to graph them, but for today, just when we're looking at the equation and we are trying to find the vertical asymptotes, in order to do this, first we can set it or factor out any GCF if we have them, but in this case we don't on number 1. And then all we have to do is set the denominator equal to 0. And then go ahead and solve that. So what I mean by that, on example 1, in order to find our vertical asymptote, or our VA, we can just take this denominator, x plus 2, set it equal to 0, subtract the 2 over, and our vertical asymptote will be x equals negative 2. That's our vertical asymptote. And it's always, your answer is going to be x equals. That will always be the case for a vertical asymptote. So the next one, maybe this one's a little bit more complicated. We have x squared minus 25. We set that equal to 0. It's up to you how you do it, but if we add the 25 over, x squared equals 25, square root of both of those, we will get x equals 5 and x equals negative 5. It could be either one. So this one actually has two vertical asymptotes at x equals 5 and x equals negative 5. All right, our next one here, x squared plus 9. If we set that equal to 0, subtract the 9 over, x squared equals negative 9. So x would equal plus or minus 3i. So this one is going to have no vertical asymptotes because those are imaginary. And then our final one here, sometimes it's instead of we can still set it equal to 0, but it's going to be a little bit more complex. We're going to have to factor this one. So two numbers that multiply here to negative 10 add up to 3. So x plus 5, x minus 2. And we're going to set both parts equal to 0. We know it'll be the opposite of both of those. So we'll get x equals negative 5, x equals 2. And these are my vertical asymptotes. One's right there, and one is right there. So vertical asymptotes are pretty straightforward. However, horizontal or oblique asymptotes are a little bit more challenging to find. In order to do that, the first thing we can establish is that while a vertical asymptote is always x equals, horizontal or oblique asymptotes are always going to be y equals. Now, if we look here, we have some different types of degrees. What I mean by degree is look at the top and the bottom. So this top one, let's establish the degrees of these. So the top one is degree 1, and it's over a degree 2. Anytime you have a lower number over a higher number, you know it's going to have a horizontal asymptote, and right here, it's always going to be at y equals 0. So that's if the degree on top is lower than the degree on the bottom. That is always the case. Now, in this next one, if they're the same, you can notice 2x squared, so that's degree 2 over x squared, that's also degree 2. They are the same. If that is the case, we divide the coefficients. Now, what I mean by the coefficients, we look at the leading terms in front of that x squared. So 2 and a 1, 2 over 1 is just 2. And so our answer then would be y equals 2. That's our horizontal asymptote. That occurs when they are the same. And when I say they're the same, meaning degree 2, degree 2. Could be degree 3, degree 3, degree 1, degree 1. They just have to have the same. Okay, so sometimes on top is going to be higher than the other. So for example, on this one, this is degree 2, it's x squared, all over degree 1. And if that is the case, you know there's an oblique asymptote. And to find it, we use long division. So we solve, and whatever we get is our answer. That is where the oblique asymptote occurs. So x squared plus 8x plus 12, we divide that by x plus 5, just like we did yesterday. I know it's going to have an x here. X times x is x squared plus 5x. We got to do the opposite then, so minus, and we get 3x, drop the 12, plus 12. Then x plus 3. So we get 3x plus 15. It's the opposite of both of those. Now, oddly enough, we don't actually care what the remainder is. The remainder does not affect us. All we care about is that x plus 3. So our answer for our horizontal asymptote is y equals x plus 3. I took that right off the top here. That's what my answer was, and that is what I get as my oblique asymptote. Now, that is only the case if it's 1 degree higher, so 2 over 1, or 3 over 2, or 4 over 3. If it's a lot higher, notice here I said high over low plus. What I mean by that is it's more than 1 degree higher, so degree 4 over degree 2. If that is the case, then there's none. There's no horizontal asymptote. There's no oblique asymptote. Yeah, we still would have to check for a vertical asymptote, but we know that there's not a horizontal or an oblique asymptote. So take a look here, example number 1. First thing we want to do is establish the degree. So this first one, degree 0 over degree 1. So if it helps you, you can write kind of low over high, which if we look up here, low over high, we know there's a horizontal asymptote. We don't have to do anything because it is always at y equals 0. So all we have to do is write horizontal asymptote at y equals 0. And that's our answer. Okay, so we always want to establish the degree first. So this next one, degree 3 over degree 2. So that's high over low, and it's only by 1. which means there's not going to be a horizontal asymptote. It'll be right here, an oblique asymptote. To find that, we got to do long division. So we set this up. X to the third plus 5x squared plus 2x minus 1. We put the x squared plus 3 out front. We know it'd be an x. X times x squared is x to the third plus 3x. We add straight down. Those are both going to be opposite. Okay, and now we can do plus 5. So we get 5x squared plus 15. We add straight down again. Those are opposites. We get negative x minus 16. That is our remainder. But once again, we don't care really about the remainder. All we care about is that our oblique asymptote occurs at y equals x plus 5. Whatever we got up top. When I say up top, I mean right up here. Okay, so the next one. This one would be degree 5 over degree 2. This is high over low, but it's plus, meaning it's a lot bigger than, it's not just 1 degree bigger, it's 5 over 2. So if that's the case right here, there is no horizontal or oblique asymptote. So okay, this next one, degree 1 over degree 3. This is low over high. So keep this top list handy. Low over high right here. Anytime that's the case, we know there's a horizontal asymptote, and it's always going to be at y equals 0. Oops, too far. So we know it's a horizontal asymptote, and this one we don't really have to do anything, just y equals 0. Okay, this next one, degree 1 over degree 1. If that is the case, then you go up here, that's going to be the same over same. So we take the leading coefficients. So 6 over 2, that reduces to 3. So our horizontal asymptote is going to occur at y equals 3. And our final one here, degree 2 over degree 1, high over low. However, it's just 1 away, 2 over 1. So remember, high over low, there's no horizontal asymptote, but there's an oblique asymptote. We got to do long division to figure out where. So set it up again. Times 2x plus 7 here. Our remainder will be 3. But once again, I don't care about the remainder. All I care about is that my oblique asymptote happens at y equals 2x plus 7. So tomorrow we're going to kind of take these and apply them. We're going to figure out how to graph them. But let me know if you have any questions. Please go ahead and try the assignment for today. It kind of explains how to do that in It's Learning. And if you have any questions, please let me know. And I'll talk to you guys tomorrow when I see you back at school. Bye.